Greetings to all of you. In today's session, we are going to discuss about intermediate chemistry, which will be helpful on the international entrance or any competitive exam if you are preparing for. In addition, India level JEE Advanced and JEE Mains, which will be helpful for IIT and NIT entrance for the engineering stream. NEET examination for medical entrance across the India. Telangana and Andhra Pradesh MSET examination for engineering entrance exam. In addition to all these, if you are preparing for any competitive exam conducted by the government organizations, in all those, general science will be the subject where the content will be very much helpful. Let's enter into our today's session. Name the following compound as per the IUPAC protocol. IUPAC stands for International Union for Pure and Applied Chemistry. So IUPAC give the rules and regulation in order to assign the name for the given organic compounds. Here is certain compounds like aldehyde, where one carbon and second one is having two carbon, three carbon aldehyde are provided. How can we assign the name for these compounds? We will go with. In order to mention the name for this aldehydes, here being it is the one carbon chain, so that alkane will be taken, root word will be taken as a methane. So one carbon chain, parent chain is the shortest here, so that being aldehydes are said to be alkanol as per the IUPAC nomenclature, so that one carbon we can mention as a methanol, it will be methanol, right? So if you move on to second compound where you can find two carbons, two carbon, parent chain will be ethane, and we will pronounce it as aldehyde can be taken as alkanol, no? So that we can name it as a ethanol. Move on to compound number 3 where 3 carbon chain will be there. Propane will be the parent chain where you can find 3 carbon aldehyde, so that propanol will be the name of the compound. Right? This is the way IUPAC nomenclature will be provided for aldehyde compounds. In common sense, we can say alkanol as the IUPAC name. Okay. These 3 compounds are designated as methanol, ethanol, propanol, respectively. This is in accordance with the IUPAC protocol. Move on to question number 2. So here certain explanation is provided regarding aldehyde as per the IUPAC. Aldehyde group present in the given organic compound on the main chain. There is, we have to exclude this E and rather we can add Al. E can be excluded, Al can be added, so that entire name will become alkanol. This is the way aldehyde main group can be designated. Alkanol for aldehydic functional groups. So this is the way we can answer IUPAC nomenclature for the given organic compound. Move on to question number 2. Question number 2 is taken from the Cambridge Assessment International Education. Here is organic compound provided. The structure of malic acid. This is said to be what? Malic acid. Malic acid is of 4 carbon chain containing this terminal carboxylic acid. This terminal is also accompanied by the carboxylic acid. We can say it is the dicarboxylic acid. 2 are there, so that dicarboxylic acid. So from this malic acid chemical structure, we need to assign what questions are there. On the structure, draw a circle around the alcohol functional group. In this compound, where alcohol is there, where hydroxy is there, we need to understand, we need to identify. That will be the question number 1. Let's see. So in this malic acid, here you can find OH over here, OH over here, OH over here as well. 3 OH are found. There is a logic in order to answer, in order to encircle this exactly alcoholic functional group, because here though it is C double bond OH, it is not said to be hydroxy, rather it will be the carboxylic acid. Entire will be the carboxylic acid only. That's why don't confuse with this OH, it will be the part of this carboxylic acid only. But when you see the carbon number 2 where you can find OH, so that we mentioned with OH, this OH only is encircled, rather COOH, COOH, OH are not considered as hydroxy. So don't get confused. So only the hydroxy laying on the second carbon is the part of a hydroxyl functional group, right? So that in the malic acid, you can find the OH on second carbon only, right? So let's see what is Malic acid. Malic acid is the kind of organic compound. We can say it is available in biomolecules, especially in fruits. These many fruits are accompanied with the malic acid. If you see here, papaya is there, grapes are there, apple is there, banana, pineapple is there, strawberries are there. These many fruits are accompanied by the malic acid, so that we can say it is the fruit component, fruit containing component it will be, right? So this is regarding what question number 1. Move on to question number 2. Deduce the formula of malic acid to show the number of carbons, hydrogens, and oxygen atoms present in it, right? So this already the entire chemical structure is provided for the malic acid. They are asking for what will be the formula. So formula represents what, how many carbons are there, how many hydrogens, and how many oxygens are there. In short form, we can represent, rather than indicating all the bonded atom orientation and the stereochemistry, everything we can exclude. Rather, just count the atoms, individual atoms present in the given compound. So if you count the carbon atoms, how many are there? C4 will be there. And oxygens are said to be 5, O5. And hydrogens are 6. So that entire formula for malic acid will be C4O5H6. This is the way we can answer malic acid chemical formula. So this is the way all the questions answered regarding this malic acid, which is given by Cambridge Assessment, International Education. So OH groups are only one OH main group is available, and its formula will be C4 1, 2, 3, 4, 5, O5, H6. This is the chemical formula of given malic acid molecule. And moreover, we have additional information, and these are the components where you can find a malic acid as an ingredient. Let's move on to question number 3. This is the question collected from JEE Advanced 2021 question paper. Okay. Among the following, the brown ring is due to the formation of. Brown ring test is the identification. Brown ring test is the identification of the certain functional group present in the given compound. First of all, we have to know what purpose brown ring test will be conducted and what will be the composition of that brown ring. Okay, so it is quite difficult to identify because all complexes provided here are iron complexes only. So you can understand that iron is the common thing whichever present in the brown ring complex. Okay, later we have to go for what will be the complex. Very simple identification for brown ring test will be nitrosyl group will be introduced. Nitrosyl. NO if present, that is called a nitrosyl. But if you see here, 2 are there, here also 2 are there, here 4 are there, but here only 1 is there. This will be the correct answer. Else will be 5 water molecules, 5 aqua, penta aqua will be there. Nitrosyl, only 1 nitrosyl molecule resides in the given complex around this central iron. The set of ligands are nitrosyl and penta aqua ligands will be there, and it is the kind of dipositive cation. So this is the composition of brown ring. Let's see how can we perform this one. Okay, if you see this test tube, you can clearly understand, you can clearly identify brown ring in between. Let's see how can we do this experiment first. This is the laboratory experiment in order to identify following reactions takes place in the brown ring test. So this is for the identification of what nitrates present in the compound, right? How can we identify? Take nitric acid in this test tube. Nitric acid will be taken over here, and ferrous sulfate is mixed in this. Ferrous sulfate compound will be mixed. Whenever ferrous sulfate and nitric acid mixed, what you are doing? You are slowly adding sulfuric acid in the slanting position by taking a dropper. Drop by drop sulfuric acid added through the walls of the test tube. We are not supposed to add sulfuric acid directly because being sulfuric acid is very strong in nature, it will expel into your face. That's the reason why the condition taken over here will be take a dropper and add sulfuric acid to the test tube drop by drop in the slanting position through the walls only. There is a serious precaution should be taken, being all are strong acids, so that we need to take great care regarding the experimentation, right? Whenever nitric acid, sulfuric acid, ferrous sulfate got mixed, there is a formation of what Fe2SO4 taken thrice will be possible, right? So if you see this here, it is in the form of iron is initially iron ferrous. Now it is converted into what? Ferric. Ferrous to ferric form, and from this NO will be liberated. NO is called what? Nitric oxide. So that only we are going to identify H3, right? This nitric oxide will be treated with iron hexacosulfate. Aquated ferrous sulfate will be treated with nitric oxide so that it will be converted into a kind of nitrosyl complex. So this is called what? Nitrosyl complex. NO is designated as a nitrosyl ligand and nitrosyl complex will be formed. This nitrosyl complex able to generate a ring in between two layers. At the junction of two layers, you can find this brown ring. Brown ring is the indication for the presence of nitrates in the given organic compound. This is the way brown ring test will be performed, and its composition will be iron penta-aquo nitrosyl dication. This is the way we can answer. For question number 3, option number D will be the correct answer. Move on to question number 4. The pair of complexes wherein both exhibit tetrahedral geometry. Okay, so here rather than one compound, more than one compound are acquiring tetrahedral geometry. We need to predict how many are there. They are acquiring tetrahedral geometry. And one more condition is, so two compounds are given, two complexes are given. Both the complexes must be tetrahedral geometry. Let's check it. So how many are having tetrahedral geometry? Here, for our convenience, they provided iron, cobalt, nickel, copper, because all these complexes are resided in these four metal complexes only. And iron is of 26 atomic number, cobalt 27, nickel is of 28, copper is of 29 respectively. This is the way atomic numbers are there, and these are the complexes provided. And moreover, some are neutral in nature, some other positive, negative, all kind of cations, anions, and neutral complexes are there. We need to identify which kind of complexes both together are acquiring tetrahedral geometry, right? So in order to go for that, let's go with one by one. So iron tetracarbonyl anion, iron tetrachloride anion will be taken. Whenever iron tetrachloride anion is taken, exactly it is acquiring, all ligands are acquiring tetrahedral corners. And these are the four set of chlorides acquiring tetrahedral corners around the central iron. This is said to be tetrahedral in nature. So, and move on to second one, iron -2 complex is there, where tetracarbonyl iron complex was given. Tetracarbonyl iron complex will be there. Again, if you see, there are all the carbonyls which are acquiring tetrahedral edges, tetrahedral corners, so that it is also said to be what? Tetrahedral complex anion, right? So we can say I am the answer. So this option number 1 itself is having both the compounds acquiring tetrahedral geometry, so that these complexes are same. I am the answer. And move on to option number 2. In option number 2, we have cobalt tetracarbonyl. So CO denotes what? Cobalt, which is the transition metal, and this CO is different with this CO. Here CO is the transition metal, and this CO will be the carbonyl, carbon with oxygen. So you can identify the sphere of oxygen, right? So based on that, cobalt is surrounded with the four carbonyls. Again, they are acquiring where? Tetrahedral corners only, so that we can simply say this cobalt anion complex will be tetrahedral. And another cobalt complex is also there, where you can find the cobalt tetrachloride dication. So in case of this one, again, all chlorides are acquiring tetrahedral corners, so that this kind of cobalt to cobalt complexes are also saying I too have a tetrahedral geometry, so that we can say this is also the correct answer. So in this question, multiple answers are given. So here also we can find both the complexes are tetrahedral. Move on to option number C. In option number C, nickel tetracarbonyl, everybody aware, nickel tetracarbonyl perfectly tetrahedral in nature. And here around the central nickel, oxidation state will be 0, right? So nickel tetracarbonyl is a perfect tetrahedral and sp3 hybridization will be there. Whereas nickel tetracyanide will be there. In case of nickel tetracyanide, it will occupy what square planar geometry, because there is a change in its hybridization. In case of nickel tetracyanide, you can find a DsP2 hybridization. In case of nickel tetracarbonyl, you can find sp3 hybridization. That's the reason why both the complexes are not exactly same. Rather, nickel tetracarbonyl will be tetrahedral, nickel tetracyanide will be square planar. This is the correct representation, which may not be the correct answer for the question. And move on to another where you can find a copper pyridine. They mentioned with py. Just they mentioned with the copper, py taken for positive. Py denotes what? Pyridine. It is the heterocyclic, six-membered heterocyclic. You can clearly see, right? So here, copper surrounded with the 4 pyridine molecules, and it is the cation. They said it is the cation, so that we can say a copper tetrapyridine complex. We can't place all the pyridine bulk heterocyclic rings in the tetrahedral corners. Rather, it is sufficiently occupying the plane. On the plane, all the pyridine rings are spatially arranged. This is the very stable. So either you can go with the chloride complex or else a bromide complex. Both are acquiring what? Square planar geometry only, in order to avoid the steric hindrance. Okay. Move on to copper tetracyanide. Again, here you can clearly see how nickel tetracyanide is occupying square planar in the same manner. Copper tetracyanide is also occupying square planar with DsP2 hybridization. So both the complexes are the part of what? Square planar geometry. So that we can exclude this answer also. Only the possibility will be cobalt tetracarbonyl, cobalt tetrachloride ions, iron tetrachloride, iron tetracarbonyl ions. So these two are the correct answers, which are provided in option A, option B. For question number 4, option number A and option number B, both are correct. Multiple options are there. So that we have to be more cautious in order to predict the answer. By getting one answer, we are not supposed to stop there. We have to check all the options whichever provided. Then only we can't miss any question. Okay. So move on to question number 5. Question number 5 is collected from the Telangana Gurukulam competitive examination for degree college lecturers. Which one among the following is biologically important and essential ultra trace element? Okay, so here biologically important means that is available, that found applications in the living organisms. And essential ultra trace element. Ultra trace means a minute quantity, tiniest quantity it will be required, but biologically important only. Very less amount it can be used, but high impact it will possess. That is called biologically important. And ultra trace element, we can say elements based on their use, we can say macro elements and micro elements. Macro means a larger quantity there will be. If you see iron, in our body, iron available everywhere, because in our body everywhere circulation of blood will be there. So that iron found everywhere. But ultra trace denotes what? Minute quantity. They exist in living organisms, but they are essential in nature. Those are called ultra trace elements. Okay, so among all the given options, copper, iron, zinc, these are also important, but we can't say ultra trace. So this first part will implicated for all 4 options. Biologically important implicated for copper, nickel, iron, zinc. But essential ultra trace element only implicated for option number 2. Because though all are biologically important, remaining 3 are used in the bulk quantity, maximum extent. But nickel can be used in the minute quantity. Let's see in what way nickel will be helpful in the living organisms. So here, metals like cobalt, nickel, and chromium all are used in the very smaller quantity, and they are very essential for biological compatibility. But corrosion products are being shown in the electrical biological responses. They will be helpful in a innate immune system. First of all, we will go with the step by step. So these kind of cobalt, nickel, and chromium metals are used in prosthesis manufacturing. Prosthesis is nothing but any body part injured which is not able to work further in an efficient manner. At that condition, we can implant artificial part which exactly resembles the existing natural body part. By means of any process, if any body part is totally injured, at that condition we can go for artificial implantation that can be made by means of either cobalt, nickel, or chromium. This is the kind of prosthetic part. Prosthetic part is nothing but which implanted, which resembles like a natural one, but it is implanted from the external source, which is called prosthesis. So this kind of metal can be taken by nickel. This is one kind of application we can say by nickel. And it also exhibit, nickel metal also exhibit qualified immunity. Immunity stands for what? Our body having defense system in order to fight against any disease causing organisms which are trying to enter, right? So that is called immunity. We have our defense system, we can develop our defense system in the presence of this nickel metal, right? And inflammations. Okay, inflammation stands for what? Wherever any kind of injury is there, any external force or injury is there, so that the body muscles get swelled, and reddishness and swelling you can observe, and severe pain also we can notice, we can experience at that condition. So inflammations can be minimized by means of consuming nickel containing, nickel enriched food materials. Nickel having tendency to suppress the inflammations. And next is about what? Protein. In order to protein can be synthesized. Protein synthesis is a kind of complex mechanism which carried in the living organisms. But here the work of nickel will be free release of protein into the body organisms are possible by means of this nickel. Nickel will help in order to release the protein into the body organisms. That is the kind of application by means of this nickel. Protein release, free release into the organisms are possible, and proteins are the building blocks of human or any living organisms, which are very essential growth factors we can say, right? So this is the way we can answer. So for question number 5, option number 2 will be the correct answer. Biologically important essential ultra trace element will be nickel, right? Move on to question number 6. This is the last question of the session. Identify the correct oxygen transport proteins from the following. Okay, so oxygen transport proteins from the following. The options provided are hemoglobin, hemoerythrin, hemocyanin. Okay, among all, the common thing will be heme. Heme means what? Iron. Iron is the common thing among all the 3 options provided. The thing is, oxygen transport proteins we need to identify. Before identifying transporting protein, first of all, we have to know about why oxygen transportation is required in living organisms. Respiration is the very common thing, and it is the routine activity by all the living organisms. Different organisms are having different adaptations in order to respirate, inhale the oxygen, exhale the carbon dioxide. Okay, that oxygen will be very much helpful in order to get the kind of metabolism. Whenever oxygenated blood entered into all the tissues and all the cells in the human organism, that oxygen used to burn the kind of complicated food materials and can release the energy within the living organisms. That is the way oxygen is very essential. Each and every part required oxygen. Oxygenated organs having efficient activity, sufficient energy as well, right? So that all the organs required oxygen. If our breath stops, what happens? Within seconds only, life can be terminated. That's the reason why oxygen circulation is very essential continuously, right? So this kind of oxygen transportation is possible by means of hemoglobin, hemoerythrin, hemocyanin. These are the proteins. All 3 are the correct options only. All 3 having the same kind of activity, they able to transport the oxygen in the living organisms. Let's see how they are able to, right? Hemoglobin, everybody aware. In human being, hemoglobin is the kind of a pigment, a red color pigment we can say, because iron is having the tendency to impart the red color, and that red color pigment having natural tendency to bind with oxygen and used to circulate among all the organisms whichever present inside you, right? So here lungs are the source in order to absorb, in order to inhale the oxygen, where oxygen get stored inside. So in these bags, oxygen storage bags we can say, oxygen will entered inside these lungs. Whenever oxygen entered, what happened, that used to bind with these red blood cells. Here oxygen diatomic molecule shown over here, and bind with these red blood cells because they having strong affinity to bind over here. And after binding with the red blood cells, they can transport it in the entire body organisms. All organisms used to be connected are having tendency to accept this oxygen released by red blood cells, and after absorbing this oxygen, they used to release carbon dioxide over here, right? This is the way we can say exchange of gases in a human, right? So after releasing this carbon dioxide, now again carbon dioxide get combined, get added with these red blood cells again. They able to carry the carbon dioxide, and whatever carbon dioxide collected from all the organs now again released into the lungs able to exhale this kind of carbon dioxide. This is a natural process, whichever oxygen entering inside called inhalation, carbon dioxide coming out is called exhalation. Natural process, every moment we can do this, right? This is the way transportation is possible inside the body. Now we will see how the kind of all proteins are showing this activity, right? So this is said to be what? Hemoglobin. Hemoglobin is the kind of coloring pigment. So here iron having tendency to bind with the porphyrin rings. These are called what? Porphyrin rings. Porphyrin rings means a five-membered ring system with pyrrole. Here one pyrrole, second pyrrole, third pyrrole, four pyrrole. Four pyrrole rings will be there around the iron, and the entire system is said to be porphyrin ring system. And here we have CH2 CH2 COO minus, CH2 CH2 COO minus. Polarity will be there, and here you can find a double bond. Here also you can find a double bond. Only the thing we need to understand is the iron having capability to absorb the oxygen and used to transport the entire body. So that hemoglobin is of accompanied by two components. One is called heme part, second is called globin part. Heme part is provided over here. This is the chemical structure of heme only. Then what about globin? Globin is the kind of protein part. Heme is the kind of metallic part. This coordination complex it will be, and globin is the part of protein, right? The entire system having tendency to transport the oxygen, right? And next is about what? We completed hemoglobin, right? Next to move on to hemoerythrin. Here you can clearly see hemoerythrin. Some of the living organisms having tendency to transport the oxygen with hemoerythrin pigment. Again, it is the kind of pigment only, because you can find iron in this, so that they are colored in nature. Any colored complex is said to be pigment, right? So this kind of hemoerythrin also accompanied by what? Here you can see again five-membered ring only, but there is one more nitrogen you can clearly see. This is called what? Imidazole ring. Here it is a pyrrole ring. Here it is imidazole ring. How many imidazole rings are there? 1, 2, 3, 4. Just like 4 pyrroles in hemoglobin, hemoerythrin also contains, 5. 1, 2, 3, 4, 5. 5 imidazole rings are present, and here 2 iron metals are there, and they got linked up with the what amino acid, that means protein part will be there. This entire will be of metallic part, and whatever aspartame, glutamic acid are present, these are said to be what? Protein part. Okay, here you can clearly see oxygen linkage between the 2 iron. metals. This is the way oxygen transportation is possible by means of hemoerythrin. Hemoerythrin is also the kind of oxygen transporting pigment in the living organisms. Move on to hemocyanin. Move on to hemocyanin. Here, it clearly represented with the copper, right? Here, metal accompanied is copper. Whatever copper is there that exists in blue color, their blood also exists in blue color. Snail is the best example, which acquires the blue color blood. Okay, so that's the reason why the entire complex is represented with the blue color, because they are acquired. How our blood is in red color, the species which are having this copper hemocyanin, they contains a blue color blood. Okay, so here you can see copper will be there. Here also imidazole, here also imidazole, here imidazole. Total, if you count 1 2 3 4 5 6, 6 imidazole rings will be there, where oxygen atoms are not attached. After attached with the oxygen atoms, it will be like a oxygenated form, right? Oxygen becoming a bridge, so which used to connect to two copper atoms like this. It works like a bridge. So this is the way what we will do. So oxygenated hemocyanin will be there, deoxygenated hemocyanin will be like this. Okay, what is the purpose of this hemocyanin? Again, it used to transport the oxygen in some organisms where oxygen can be supplied into the entire organism, entire organs. Okay, so snail is the best example, which fall in this copper containing pigment for the oxygen transportation. This is the way we can answer all 6 questions. For the 6th question, in order to transport the oxygen, the proteins required are hemoglobin is the oxygen transporting protein. Hemoerythrin is also the oxygen transporting one. Hemocyanin is also the part of oxygen transporting protein. So that A, B, C are correct, which are available in option number 2. For question number 6, option number 2 will be the correct answer. This is the way we can go with all the contents in the detailed way. I hope the session will be very informative to you. And I collected the entire information by the assistance of Google. And thanks for the entire information which I were provided. And so many platforms I visited in order to acquire the right information for all the questions whichever answered over here. I must thankful to all the platforms whichever gave the information to me. And I'm sincerely requesting to like the channel, because by doing this one, I'll get the encourage in order to do more such kind of things in the near future. And comment really which part is important for you and which is interesting in the session, and share with the aspirants who are seriously preparing for any entrance or competitive exam as well. Subscribe the channel in order to receive more such kind of updates in the near future. Thank you very much for your patient listening. Thank you one and all.